Most people assume that all crypto works the same, but here's a secret you only discover when you actually use it. Bitcoin can take an hour to move, Ethereum can cost £50 when things get busy. And then there's Solana, which feels like you've stepped into an entirely different world. So today, I want to explain why one blockchain feels like email and the other feels like sending a letter in the post. I'm going to break down what Solana is, the problem it's set out to solve, and the simple idea behind it that makes it very different from Bitcoin and Ethereum. I've also included a really easy analogy that I hope will help everything click. And by the end of this video, you'll understand why some developers still choose to build on Ethereum and why others are now experimenting with Solana instead. So Solana is a blockchain network built to run programs rather than simply handle payments like Bitcoin. Its currency, Sol, powers the network and can be invested in much like ETH on Ethereum. It was created by a group of engineers led by Anatoly Yakovenko, who began developing it a couple of years after Ethereum went live. They felt that blockchains like Bitcoin and Ethereum could feel slow and expensive for the end user, and they wanted to fix that. So what do I mean by slow? If you've ever held your Bitcoin or Ethereum in a personal wallet rather than on an exchange like Kraken or Coinbase, you'll know exactly what I mean. Anytime you want to sell your coins or use that crypto to buy something else, you first need to transfer it onto an exchange, and that transfer is the part that takes the time. On Bitcoin, it can be anything from 10 minutes to an hour. And on Ethereum, it's usually 15 seconds to a few minutes, depending on how busy the network is. And then don't forget there are the transaction fees. Moving Bitcoin might cost you £1 to £20 or more, and moving Ethereum can jump from £1 to £50 plus when the network is really busy. And when lots of people pile in at the same time, both the wait time and the cost can suddenly shoot up. And the funny thing is, these fees, they don't depend on how much you're sending. You could send £10 or £10,000 and the fee is basically the same. You're paying for space on the network, not the size of the transfer. Which is why being strategic about when you move your crypto on and off an exchange can actually save you quite a bit of money. This is the problem that Solana set out to fix. It was designed to remove as much of that waiting and cost as possible, so the network could feel fast and cheap no matter how many people were using it. So how did this group of engineers manage to do this? It started with a really simple observation. Most blockchains, including Bitcoin and Ethereum, they spend an enormous amount of time trying to agree on time, literally the order of events. Things like who sent money to who first, which transaction should go next, and which computer in the network gets to add to the next block. Because there's no shared internal clock, every computer on the network has to constantly check with all the others to make sure they're all seeing the same sequence. And all that back and forth creates the delays and the higher fees that you feel as an end user. So these engineers, they asked a very simple question. What if the blockchain had its own built-in clock? A clock that every computer could trust without having to talk to each other all the time. And that idea became proof of history, Solana's massive breakthrough. Here's an easy way to picture it, or at least it was helpful for me. Imagine you're walking into a passport office where you need to check in at a machine and receive a numbered ticket. The moment you check in, the system assigns you a number, 42, 43, 44, and that number clearly shows where you sit in the queue. Nobody in the waiting room needs to debate who arrived first, and the staff don't need to double check the order. When the screen calls 42, everyone knows exactly who's next. And Solana, it works in a very similar way. Every transaction gets its own ticket number the instant it enters the system, essentially a timestamp that proves the moment it arrives and where it sits in the sequence. And because the ordering is known immediately, the computers on the network don't need to talk to each other to agree on what's next. And once you remove all that coordination, everything speeds up. Transactions confirm almost instantly and fees stay tiny. A shared clock, it sounds simple, but it's what allows the entire network to run at a completely different speed. Most of the big, serious financial projects, they still use Ethereum. It's been around the longest, it's the one institutions feel most comfortable with, and it has the biggest ecosystem. More developers build on Ethereum, and more financial activity flows through it than anywhere else, including the biggest stablecoins, which are basically digital versions of pounds or dollars that stay the same price as the currency they track. A lot of this early stablecoin infrastructure started on Ethereum. But when people actually want to use stablecoins for fast, everyday payments, Solana is becoming the popular choice because it's just so much quicker and cheaper. And when you look at apps that need real speed, anything where the system has to update immediately behind the scenes, things like payments or games where players can earn or trade digital items, more developers are choosing Solana because the experience for the end user is dramatically smoother. Even if users don't realise a blockchain is involved, they definitely feel when it's fast or slow. So that's the core difference between Ethereum and Solana. One is trusted infrastructure, the other focuses on speed. If you found this helpful, don't forget to subscribe for more beginner-friendly content. Many thanks.